So this is a series of questions kind of about like renewable energy, the national grid, things like that. So the first question asks you to fill in the table. We've got 25 is the saving per year. How much would you save in 10 years? So you're going to do 25 times by 10, which is going to give you 250. Okay. This is then the opposite way around. So you make 1,000 in 10 years. So 1,000 divided by 10 is going to give you 100. So that's your saving per year. That's your saving over 10 years. Payback time then is cost over saving per year. It says calculate the payback time for solar panels. Okay. So solar panels cost 2,400 to fit. You save £150 each year. So it's going to take you 16 years to pay back that £2,400. Right, so this is looking at different pollutants. Okay, the ones we're going to be focusing on is carbon dioxide, which causes global warming, and sulfur dioxide, which causes acid rain. Okay, you are looking for the one that has the least impact on global warming. So that's going to be the one with the lowest CO2, which is gas. Okay, again, looking for the least acid rain. It will also be gas because it has the lowest amount of sulfur dioxide also released. Okay, but be careful as to acid rain is to do with SO2. Global warming is to do with CO2. In this power station, it's similar to fossil fuel power stations because both types have turbines and generators. State one way, they're also similar. They also use steam to spin the turbine to generate the electricity. Give one advantage of geothermal power compared to solar power. It's more reliable, okay, because you're not relying on the sun, okay, which is where you rely a lot on weather with solar panels. Nice, easy question there. Just be really careful. 3 marks. Don't lose any marks. Okay, you are looking to plot. Okay, so the first one is 1. You're going to find 1 on your graph. Okay, then it says 40. So you're going to go up to 40 and put a little cross. Okay, cross, 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 cross. Suitable line. That can be a curve if it needs to be. Okay, so just be careful of that. But this one is a line. Nice line through. Okay, we do not dot to dot. Okay, do not dot to dot unless they ask you to. Okay, that is wrong. Use the graph to find the distance the water would have been pumped down to reach 150. So go up to 150, go along, would give you 6.5. The power station is able to provide, and look at that number there where they've converted to watts for you, for supplying homes. Calculate how many homes the power station would supply if each home used 2,000 watts. So you're going to use 2,400,000. divided by the 2,000, that means that you can supply 1,200 homes with that amount of energy. Look at that because they're both in watts. They've helped you out there, okay? Ignore that. You don't need to know that. 2.4 megawatts. Big question here with a lot of information, okay? Look at the bullet points. Don't overcomplicate it. Use your knowledge and information from the table. Compare the cost-effective and environmental impacts of the 2 methods of generating electricity. The cost of generating electricity is cheaper than wind, okay? So just work your way down, okay? So that should say the cost of using a nuclear power station, okay, is cheaper than wind. So the cost there is 2.8, whereas that's 5.6. Okay, so work your way down. So I've ticked that, I've used that information, okay? A nuclear power station produces 8,000 times more power. So you could have just said it produces more power. Okay, you can see that there. Again, give yourself a tick. Therefore, to create 1,800 turbines to create the same number of power as one nuclear power station. So that's going to require a lot more space, thinking about habitats and space. Okay, that means that it would then cost 5,400 million compared to the 4,000 million it would cost to make a nuclear power station. Wind turbines do not produce waste. Nuclear needs to be disposed of, so that's a big problem. It's very expensive and it's dangerous to the environment. Okay, it can cause radioactive problems if it's left alone, whereas that wouldn't happen with a wind turbine. This could also be looked at with the decommissioning cost. So it's 4,000 to decommission a nuclear power station, where it's only 3 million to decommission. Okay, so that means when they're done with their lives, it's a lot more expensive to decommission a nuclear power station. Offshore produces around the same amount of carbon footprint as a nuclear power station, whereas onshore doesn't. Okay, so there's again a little bit of something to think about. Just bullet point it. Look at the information, tick them off as you go. Just talk about each one. Another one that I didn't mention, but I've just realised, is nuclear power stations have a larger lifetime. So that means that you could have you'd have to set up three wind farms for the amount of time spent on a nuclear power station. Okay. Again, information here, which is going to go on to the next page to plot a graph. Rotor diameter, maximum speed. Okay, so that is the independent variable, that's the dependent variable, that goes on the x, that goes on the y. Nice little graph here. Okay, can you see that this one is a curve? Okay, this one is a curve, so you need to curve it. You wouldn't have got the mark if you'd drawn a line of best fit through it. Okay, can you see how this is worth 2 marks? Okay, so as rotor diameter increases, the maximum power output also increases, okay, at an increasing rate. That's what that curve means, okay? You would not be asked to use that equation. Homeowners generate electricity from solar panels to save money and get paid for the energy they produce. State 2 ways using solar panels benefits the environment. They're renewable, they do not produce CO2, so cannot contribute to global warming. For a typical 2.4 kilowatt household, or that's 2,400 watts, the installation of solar panels are 1,100 a year, okay, from the generation tariff, 880 a year from the export tariff, and 120 a year reduction of current electricity bills. Okay, so that's the money that you make having solar panels. Add it all together, and that's how much you save every year. Okay, it costs 7,800 to install them. Okay, so you're doing the payback time equation, cost over the annual saving. So it would take you 6 years to pay back in total what you spent on the solar panels. State how payback time for solar panels will be effective if the power output of the panel is less than 2.4. Okay, so payback time would increase because you wouldn't be generating as much electricity. Give 2 reasons why power output from the solar panel may be less than 2.4. Less exposure to sunlight, lost in other energies maybe. It might have generated a sound for some reason, or another light. It might have been a really bad weather situation, so we had no weather. They might not be pointing directly at the sun. They might not be angled correctly. Solar panels need to be angled correctly so that they're near enough by the sun. So that's another reason why you might not get a good enough output. Okay. 1 unit of electricity costs you 15p. Calculate how many units must have been produced to save this homeowner 1,200. Okay, so and they put it in pence for you, which was really nice. So the savings was that many pence divided by 15, so 800 units must have been generated. Can you see how you've got the equation by there? You just need to input your answer in. Okay, then it goes on to say that power, which must be measured in kilowatts, so you use your answer for this one, units used, okay, divided by the power, so the hours that would be needed would be 333.3, okay. Use the information. That was nice because they told you saved there in pence, and they told you that was the cost per pence. Okay, state 1 non-environmental advantage of generating electricity in a hydroelectric power station. It's more reliable than using stuff like wind turbines, solar panels, stuff like that relies on the weather. A risk, flooding is the big thing. Landslides is another big thing that could happen here. Okay, the need for electricity changes throughout the day. Okay, which times of day is the demand for electricity greater than the supply? Okay, so you're looking for times when, and it hasn't come out very well, but there should be like a line along there. Okay, so the demand is above the supply, so you're looking for these peaks here, which is 7 to 9 and 5 to 7. Okay, so when the demand is going to be bigger than the supply. In the early hours of the morning, the water in the lake of the power station is pumped back to the upper reservoir. By looking at the graph opposite, explain why this is done. Because demand is much lower, so the supply of power can be used to pump the water back up. Okay. Then this goes on to talk about the national grid. Okay, the national grid is a series of wires and pylons that transmit electricity from a power station to your home. Okay, you've got all your series of wires and pylons in the middle here. Okay, by here, when it comes out of the power station, it enters into a step up transformer. Okay, these step up transformers increase the voltage, okay, entering these power cables and these power pylons from the power station. Okay, voltage is then increased, current is reduced. Okay, so this reduces energy loss, so it actually moves really quickly along these wires without losing loads of energy, because you don't want all of your energy to be lost as heat, because it's going to be traveling quite fast. You don't want it to be lost as heat. Okay, when it just before it reaches your home, it needs to go into a step down transformer. Step down transformers then decrease the voltage again, make it safe for your home. Okay. Describe the role of the national grid. The national grid is a series of power stations connecting power stations to consumers to provide them with electricity, even if some stations fail. Explain what X and Y are. X is a step-up transformer, steps up the voltage, increases the voltage, okay, so reduces energy being lost as heat. Step Y is a step down, decreases the voltage, so it makes it safe to use. Okay, so not all consumers can access the national grid. An isolated farm with 5 sheds in a rural part of Mid Wales is not connected to the national grid. The farmers need to generate electricity for his sheds, and he chooses a biomass generator. He then uses wood pellets and chipwoods as a source of energy and has a capacity of 100 kilowatts. Each shed is supplied by 230 volts with a maximum current of 180. The farmer thinks this generator will supply enough power for his sheds. Okay, use the equation to determine whether the 100 kilowatt generator will supply the 5 sheds. So the power into one shed is going to be 230, so voltage, which is there, times by the current, which is going to give you 18,400 watts. Okay, if you convert that then into kilowatts, that's 8.4 kilowatts. Okay, he's got 5 sheds, so times that by 5, so that's going to be 9.4 kilowatts. Okay, needs to be less than 100 kilowatts, so you would be able to power them. That is an all right question. It's 4 marks. Just take your time, think about it. So what information did you had? You had the voltage and the current for one shed. Okay, then work it out for multiple sheds. Explain the environmental advantage of using a biomass generator. Okay, biomass is when you use like wood that you've cut down, like kind of plants and stuff. You heat that up to generate the electricity, or you generate the heat that spins the turbine, etc. Okay, the reason for that is obviously it's waste, so it's using waste product. It's also carbon neutral, so it does not release any extra CO2 into the atmosphere, so limits the effects of global warming. State what is meant by renewable energy. We can keep using this energy and it will not run out. State 2 advantages other than cost in increasing the use of renewable energy. Less dependence on fossil fuels because they will run out. Doesn't contribute to global warming because they don't release CO2 when they burn. Okay, you could have also, they're not burning though, so when we use them. You could also have mentioned about sulfur dioxide and acid rain. Okay, calculate the total number of electrical units that were generated by renewable sources in 2016. So you are just adding them values together, and you should have got 5,443. Calculate the percentage made by solar panels. So that is the total we've just worked out. That is just solar panels. Make sure you times it by 100, so it'll give you 14.4%. Suggest that the electricity generated using solar panels has increased the most between 2012 and 2016. So you are basically looking for the difference in both values for both of them. So these are the 2016 values, these are the 2012 values. So I took them away from each other, and these are the energies that I got. Okay, actually the highest was the wind. Okay, so it's actually far larger increase in energy generated than the solar panels. Name this source of energy. That would be solar or wind. They would have been the two sources of energy you could see in there. And then you had to fill in the blanks here. So coal, an energy source that burns in power stations. Nuclear fuel, an energy source used in power stations at high decommissioning costs because it's radioactive. The sun, the energy source that supplies solar panels. And wind, an energy source that drives turbines directly.